In this video, we will discuss modus tollens. It is a deductive form of reasoning. It consists of two premises and a conclusion. A premise is a statement, and statements can be true or false. So when you're making arguments to support some conclusion, we'll call those statements or reasons that you're giving premises. So premise 1 would read, if P happens, then Q will happen. When you see this arrow in logic, that indicates that this is a conditional statement. A conditional statement has an antecedent and a consequent. Whatever comes before the arrow is the antecedent, and whatever comes after the arrow is the consequent. So in premise 1, if P happens, then Q happens. In other words, Q is a consequence of P. If P happens, then Q happens, and we move to premise 2, you see this squiggly line. In logic, we call that the tilde. A tilde is a negation. So the way we would read premise 2 is not Q. A negation just means that you're taking whatever this variable or proposition is and saying not. So you could say it is not the case that Q, or Q does not happen. You just need to find some way to take Q and negate it. The conclusion is denoted by these 3 dots, which is a common symbol for thus or therefore in logic. Therefore, not P. Another way to think of modus tollens is by saying that we are negating the consequent. So that's just a fancy way of saying that we are saying not Q. So Q is the consequent, P was the antecedent. We are negating the consequent. Therefore, we are negating the antecedent. If you can get your argument to fit neatly into this form, your argument will be valid. One thing that's very important to keep in mind throughout this video: validity does not equal truth. Your argument can be valid, but that doesn't mean it's true. When we deem an argument valid in this video, all we're saying is the form of the argument fits this form. We're not saying the argument's true. The second most important thing to keep in mind is the word sound. A sound argument is valid in its structure, and all of the premises are true. So if even one of these premises is false, then that argument is not sound. Gold standard then is to work toward making sound arguments so that our conclusions are guaranteed to be true. Let's now do some examples of modus tollens. If it is raining, then the ground is wet. P, then Q. P, then Q. Premise 2, the ground is not wet, not Q. Therefore, it is not raining, not P. So this is a valid argument because it fits the modus tollens formula. Now we know that the argument is valid, and we have to now test for soundness. So again, if both of these premises are true, then this argument is sound, and this conclusion is guaranteed to be true. If one of the premises is false, then this argument only remains valid. This conclusion is only guaranteed to follow, not guaranteed to be true. Now our job is to challenge the premises. Is there any counterexample to premise 1? If it is raining, then the ground is wet. So at first glance, this sounds correct. Many people would evaluate whether it rained last night simply by looking out the window and seeing that the ground is wet. But in logic, we want to make sure that this is true all the time. Is it really true to think that just because it's raining, that must mean the ground is wet? Can you think of any examples where it could still be raining, but for some reason the ground is dry? For example, under your car, the ground could still be dry because it was covering that piece of the ground. That doesn't mean that it wasn't raining. So it's not fair to conclude that since the ground's not wet, that means it didn't rain. It still could have rained but been covered with a sandbox, a table, an umbrella, an awning. So just because at first glance this seems like good logic, it's not always true. This argument is valid simply because it follows the Modus Tollens formula, but the content of it, the argument itself, is not true. This argument is not sound. For it to have been sound, it needed to have both of these premises true and the correct form. Let's do another example to see if we can now come up with a sound version of Modus Tollens. All right, in this example, premise 1 reads, if it is a cat, then it is an animal. If P, then Q. Premise 2, it is not an animal, not Q. Therefore, it is not a cat, not P. So we know this argument is valid because it fits our Modus Tollens form, and the next step is to evaluate for truth. Is this argument sound? Are both of the premises true? Can you think of an example where something could be a cat but not be an animal? The answer is no. By definition, all cats are animals. When we move to premise 2, and they say that it is not an animal, we're assuming that the thing in question, the it that is the subject of premise 1, truly is not an animal, and therefore it is not a cat. So since the thing in question isn't an animal, it can't be a cat, but it also couldn't be any other animal. This argument is sound. This conclusion is guaranteed to be true. We're assuming that the author of this argument truly is saying that the thing in question is not an animal. If it's not an animal, then it's impossible that it's a cat. It's impossible that it's a cat because if it's a cat, then it's an animal. So since cats are animals, and the thing in question is not an animal, then it is impossible that it's a cat. So this is our first example of an argument under Modus Tollens that is sound. It's valid, all the premises are true, the conclusion is not only guaranteed to follow, the conclusion is guaranteed to be true. What do you think would happen if we put not P in premise 2 and concluded not Q? In other words, could we just switch these two variables, P and Q, around? I'm going to take this same example, I'm going to switch the premise and the conclusions variables around so we could see if the reasoning still holds up. What I did here was I switched P and Q to see if the argument would still hold up. As a quick refresher, whatever comes before the arrow is the antecedent, and whatever comes after the arrow is the consequent. So in Modus Tollens, right here in premise 2, we would put not Q, which would be denying the consequent. But here, they are denying the antecedent. They're denying P. In the conclusion, we are denying the consequent. The content on the board is exactly the same. I didn't add or remove anything. All I did was switch these two premises. If it is a cat, then it is an animal. That's true. Premise 2, it is not a cat. The conclusion is that it is not an animal. Can we safely conclude that this thing in question, the it, is not an animal just because it's not a cat? Surely, just because the thing in question is not a cat does not mean that it's necessarily not an animal. The it in question could have been a dog or a bear. If it were one of those things, it wouldn't have been safe to conclude that it's not an animal. So what you see here is something called a fallacy. A fallacy is an error in reasoning. This formula here looks very similar to Modus Tollens, but it is not. This is invalid reasoning. Any argument that fits this form is invalid. This fallacy is called denying the antecedent. because in premise 2, they're denying the antecedent rather than denying the consequent. So in Modus Tollens, we deny the consequent only. Right off the bat, this argument could never be sound. For it to have been sound, the form needed to be valid. This form is not valid. So since it's invalid, it's already not sound. But it also happens that the premises do not guarantee that this conclusion is true. Just because this thing is not a cat does not mean it's not an animal. But if we put it's not an animal here, then it's guaranteed to not be a cat. What's fascinating about this example and this fallacy of denying the antecedent is that there is no new information on the board. The premises and the content is the same. All I did was switch these two statements. By switching the statements, I have now created an invalid argument. The reasoning is not sound, the conclusion does not follow, and it's not true. So keep in mind that just because this formula here looks similar to Modus Tollens, it is not. If you use this formula, your reasoning falls apart, it's not credible, and it's not valid. So be sure to be able to recognize this common error in reasoning.